Good morning, guys. This is Mr. Sullivan here. I'm just going to go through with you the sheet that I passed out yesterday that was the vocabulary terms for geometry, and it's served as an introduction to what we'll be talking about over the next couple of weeks. So I just wanted to go through with the assignment was to basically fill out in this first one, what do you think these vocabulary words meant? And then I wanted to provide you with the correct definition and then a visual to go with it. So if you have not filled it out, you can still go back into the Google Slides and you can fill out what you thought it meant, but you can also copy down what my definition is, and you can do a visual picture. Maybe if it doesn't work in the document, you can just create a visual on a separate piece of paper. But this is used as a reference throughout the next few weeks for vocabulary words that might be new to you or words that you might need a refresher in. So just going through the first one, what a point is. So a point in geometry is the exact position or location. So it is the exact position or location. And to do a picture of that, a point is basically something that looks like this. Okay, and you'll see that in geometry because we start to connect lines and line segments and also rays. And you might see parallel lines with all of these things. So a point is just defined as this, as the exact position or location. Okay. To move on, a line is a straight path that extends in both directions with no endpoints. So it's a straight path that extends with no end points. So what this looks like is exactly what you think, a line. Okay, it extends, no straight path, no end points. Okay, so it can keep continuing and continuing. A line segment is different because line segments are a part of a line, a part of a line that includes 2 points called endpoints. And there could be points between them. And there could be points between them. So a visual, when I think of a line segment, is it could be something as simple as a line. Here are my endpoints that we're talking about. These are called endpoints, here and here. And you might see that they might have like A and they might have a B, but sometimes we can have a line that will look like this. Excuse my little crookedness. And we might have another point in the middle. So we have A, we have B, and we might have C. So you might identify A to B is a line segment, B to C is a line segment. You could also say A to C creates a line segment. So these points on this line are what makes it a line segment, because this is different than a line because these have endpoints. These do not. Now, moving on to a ray, like a ray of sunshine. A ray is a part of a line, a part of a line with one endpoint and it continues in one direction. So most of you will think of like a ray of sun. And if we think of the sun, my visual, how I remember it, here's my sun. We have all of these little lines coming out. These are what are called our rays. It's a part of a line with one endpoint. So here's my endpoint. and it continues in one direction. Okay, here's my endpoint, one direction. And it continues infinitively, just keeps going. Okay, until you were to add another line segment, which would make this line end. But this arrow indicates that it extends and it keeps going and going. So this is called a ray, one endpoint, and it extends in one direction for the foreseeable future. Now we come across parallel lines. And what are parallel lines? Those are lines in a plane figure, I should say, not the plane in the sky, with length and width. Okay, so parallel lines. Okay, they have a length to them. They have a certain width to them. In this case, they're both the same. Okay, but one thing to keep in mind is parallel lines will never cross. They will stay side by side. Okay, and they will never at one point ever meet, and they will never cross one another. Okay, now moving on to the next thing, which is parallel. Parallel basically means to not cross, or something that is parallel is side by side. Okay, so I could have parallel this way. I could have parallel this way. Okay, and when I think of parallel, I think of parallel parking. So if we had a parking spot right here, okay, and we had another parking spot right here, if I were to back my car in, I would park my car right here, and someone else would park their car right here, and we would be parallel to the side of the road. The curb would be here, the street would be here, and our car would be parallel to that road. Perpendicular basically means lines that intersect to form right angles. So lines that intersect to form right angles. Okay, so here we go. We'll have one cross, and I'll have another one cross here. Now, when we talk about a right angle, we're talking about 90 degrees. Okay, so think of like the intersections, the perfect intersection in the neighborhood. If you came up, there would be a four-way stop sign here. Okay, right here, this is perpendicular because this is 90 degrees. This is a right angle, perpendicular, 90 degrees. This one would also be 90 degrees. And on this side, 90 degrees. But you could also have a line that goes like this, and then you could have one that goes like this. But this is still perpendicular because they are perpendicular lines because they form a right angle right here. They form a right angle right here, and right here. Okay, so one thing to remember, they have to basically intersect if they're perpendicular, and they form a right angle 90 degrees, okay, where the two lines meet. Then we have the definition of an angle. And angles are basically the figure formed when two rays or line segments share the same endpoint. So share the same end point. Okay, so in this case, we could have, I'll just do a little diagram. We could have something like this. So here's two rays. I'll have those keep going. Here's my end point. But then right here, this part right here forms my angle. Okay, and in this case, we have an acute angle because it is less than 90 degrees. Okay, I might have another one like this. I could have a line segment that goes here, endpoint here, endpoint here. I might have an endpoint go this way. Okay, and then right here, we're talking about this, where these points meet, is called the angle it creates. Now, a vertex builds upon an angle. And a vertex is two or more curves, lines, or edges that meet. So for instance, if we have here to here, okay, this part right here where these two lines meet, that is called a vertex. Okay, if it has more than one, we ask, well, there's how many vertices, okay, for plural. So if I had a square, for instance, okay, we have a vertex right here in this corner. We have a vertex in this corner. We have a vertex in the top right, and we have a vertex in the bottom right. Okay, so these are called vertices because there are 4 of them in this particular case. This is just vertex because I'm only showing you one where these two endpoints meet. Okay, but it's wherever the two lines meet together. It could be a curve where the edges meet if it was a 3-dimensional shape. Okay, moving on to acute. Oh, isn't that cute? That's how I think of it. Acute. I think of cute as in, oh, he's so small, he's so cute. Okay, like a little baby. So acute is something that is an angle less than 90 degrees. So less than 90 degrees is acute. Okay, so it is also an angle that is like this. We have two lines. They meet together. I have a vertex here. So this angle I know is an acute angle because it is less than 90 degrees. And if I show you by just going like this, here we have a 90-degree angle. This is smaller than a 90-degree angle, so it's probably about 45 degrees if I had to guess. So in this case, this 45-degree angle is acute. Okay, moves on to the next one. Obtuse kind of comes from, if I think of obese or bigger than 90 degrees. So this is anything up to 180 degrees. So greater than 90 is obtuse. So in this case, if I have an angle, let me draw my line. I will draw something out to here. Okay, this dotted line indicates a right angle because right means 90 degrees. So because this extends past 90 degrees, this is called an obtuse angle. Okay, so it is greater than 90. If I had to guess, this is probably 90 right here, plus about 45. So this entire angle is probably about 135 degrees. Okay, I know a straight line is 180, so it's about halfway in there. So I know that somewhere in here is probably about 135 degrees if I estimate. Now the one thing on here is not given is a right angle. And a right angle is exactly 90 degrees. Okay, so that would be your perfect straight one down, perfect line across, and then you usually see a box in the corner indicating that this is 90 degrees. Okay, most of your stuff around your house, if you look at your tiles on your floor, if you look anywhere, picture frames, things like that, objects around your house, most of them have right angles in them. Very few have acute, obtuse, but it doesn't mean that there aren't any. The majority of things are perfectly square. So the ones that we think of as perfectly square are the right angles. Okay, so in this case, this is a right angle. Okay, I hope this was helpful to you. On your actual document, if you could fill in the vocabulary word and then a picture to help you remember what they mean, I think it'll be helpful for you going forward so that you have something to look at. I'm very confident that you guys know how to do this because we have done so much practice already in school from ST Math and other things, but I hope this will help you with some guidance to upcoming lessons. Thank you for listening. Hope I wasn't too boring.